Hello, my name is Carrie Locke. This is CS115, Introduction to Computers, and this is Chapter 2, the Internet. This chapter is a lot of fun because the Internet is something we use every day, and it's permeated every aspect of our lives, and we're going to try to demystify it, and we got a lot of fun things in store for you. So just as an overview, we're going to start with some housekeeping, and we're going to go through the different sections of the chapter. There's a couple of extra things in here, like some of the current issues, some of the things that weren't included in the chapter. And we're going to do a chapter summary, and then we're going to go over some assignments, the assignments and the projects that are due. So for housekeeping, I'll distribute the content at the beginning of the week. Any testing will be on Fridays. Assignments and projects will be due at the end of the week. Any changes I'll announce through Web Campus. This Friday, there will be a syllabus quiz that will be available to you on Friday. For the syllabus quiz, it's going to be an open book quiz. Don't worry too much about the syllabus quiz. The syllabus quiz, it'll be available to you on Friday. It will be an open book quiz. So week 1 and 2 assignments. The grades for the discussion have been posted on Web Campus. The Discord grades should be up this week, and the plain text assignment grades should be up this week also. Chapter 2, the Internet, fun. For this week, you have 2 projects. One is an email and search engine project, and the other is you get to build a web page. Yay, you get to build a web page. So if you've never done that, that'll be a lot of fun. I'll explain those a little bit later. The evolution of the Internet. The Internet started as a research project funded by the DoD, ARPA, Advanced Research Projects Agency. There were different locations, different research institutions, 4 to be specific: UCLA, UC Santa Barbara, Stanford, and University of Utah. So the idea was, could they share information on military and scientific projects, and could it be fault tolerant? In other words, if there was a disaster such as a nuclear attack, because this was the Cold War era, if there was a nuclear attack, could it withstand a nuclear attack? Could the information still travel? Now, each network host, each research institution was a server. These were very large servers. In 1969, Leonard Kleinrock at UCLA sent a letter to a different model of computer at Stanford. So he was intending to send login. He sent the L successfully. He sent the O successfully, and then the system crashed. So from that failure came the Internet. So from failures can come great things. The Internet. The Internet is not real. So it's not real. It's not a thing. It's not a place. It's not a company. It's not an agency. So let me explain what I mean by that. It's actually an agreed upon set of rules. So when somebody says the Internet went down, the Internet crashed, it's not true. It's their specific connection to the Internet went down. The Internet can't go down. That's the design of it. So it is an agreed upon set of rules that allow devices to connect to each other. A network is a connection of 2 or more devices. A LAN is a local area network. That would be a connection of 2 devices. Your home network is a LAN. That is a local area network. Now, when your home network connects to the larger network, that is a WAN, a wide area network. Those are the big networks. So the internet is actually a network of networks. The original term for the internet was an internetwork, which means that it interconnects, networks interconnecting. It was shortened to internet. In 1974, the networking group created an RFC, a request for comment. Those still exist today. So those still exist today to decide the rules that we decide upon for the internet. And that decided the term internet. It moved the term from an internetwork to internet. Again, the internet is decentralized and fault tolerant. The internet is as fast or as slow as the hardware that connects the internet, connects you to the internet, or connects the devices between other devices on the internet. Connecting to the internet. So users connect their devices to the internet either through wired or wireless technology, and they access the internet through services either free or for a fee. So the user's device transmits wirelessly to a modem, or their computer connects a wired connection to a modem. And then they connect to a broadband internet service. Now, broadband is defined as a high-capacity transmission that uses a wide range of frequencies and enables a large number of messages to be communicated simultaneously. So, different examples of wired connections. Your cable internet service provides high-speed internet through your cable television network via your cable modem. DSL, or digital subscriber line, provides high-speed internet connection through the telephone network via a DSL modem. So fiber to premises, FTTP, uses fiber optic cable to provide high-speed internet access via a modem. Wireless connections. Wi-Fi. The book says that Wi-Fi is wireless fidelity. This is a common misconception. You can look this up. You can research this. Wi-Fi was just a really cool term that they thought up. It does not actually stand for anything. It's not short for anything. They just, hey, let's think of a really cool term, Wi-Fi, and it stuck. So Wi-Fi uses radio signals to provide high-speed internet to devices with Wi-Fi capability. Mobile broadband, high-speed internet connections over the cellular radio network. So that's your 3G, 4G, 5G. Fixed wireless, high-speed internet connections using a dish-shaped antenna on a building, such as a house, business, to communicate with a tower via, again, radio signals. Satellite, high-speed internet connections via satellite to a satellite dish that communicates via a satellite modem. So satellite you'll see quite often in rural areas. One thing that they did not mention here is microwave. Microwave technology is another wireless connection technology, and that uses microwaves instead of radio waves to transmit the data. So dial-up access. Dial-up access was the older way to connect to the internet. So I've got something here that I want to show you. Now, if you're using headphones, you'll want to make sure that you turn the volume down on your headphones. So I'm going to go ahead and explain it while you take a minute to turn down the volume. So dial-up access uses a modem in your computer and connects to the internet via your regular telephone line. And it uses analog, so it's not using a digital signal here, it's using analog signal. So I'm going to go ahead and play this. Oops, wrong one. So I'm dating myself here, but that sound was just the greatest sound, because that sound meant that you were connecting to the internet. That sound, for those of us that used to use a dial-up connection, we loved that sound because it was like, yes, we're connecting to the internet. So that sound, if anybody who used to use a dial-up to connect to the internet back in the day when that was how you connected to the internet, that sound is just heartwarming. We know that sound very well. So I wanted to share that with you. All right, a hotspot. A hotspot is a wireless network that provides internet connection to mobile computers and devices. You've probably heard about hotspots. Most hotspots enable unrestricted or open access. Some require you to sign user terms of service, obtain a password, perform some other action, clicking on an agreement, that sort of stuff. So tethering is very similar to a hotspot. Tethering, when you use your smartphone or internet-capable tablet, and then you use your device sharing when you allow somebody else to connect through your device to the internet. Hotspots are also available. You can carry around a little MiFi type of a device, which can turn into a hotspot. They'll use 4G, 5G to use the cellular towers to connect to the internet. Internet service providers. They provide internet access. So there are businesses that provide individuals and organizations wired or wireless access to the internet for free or for a fee. Generally, they're fixed fees, and they offer a variety of plans based on how much speed you want, bandwidth you want, and other services. They quite often bundle other services with your internet access, such as news, weather, financial data, games, email, online storage. Bandwidth. Bandwidth is the amount of data that travels over a network. The higher the bandwidth, the more data that you can transmit. So data sizes. This is where we're going to get a little bit geeky. So there are 8 bits per byte. So I've got here a representation. These are all in ones. There's no zeros. So you've got 8 ones. So 8 bits in a byte. Now, just for fun, the computer science geeks, a nibble is actually 4 bits. So binary is not equal to decimal. And this upsets a lot of people when they receive their hard drive and they expected a specific amount of data space, and then they get a lower amount of space. And this is why. Because in binary, it's 1024, and in decimal, it's 1,000. So for every 1,000 in decimal, you lose 24, because in binary, it's 24. It's 24 extra. And that's just the way that the calculation works. And unless you want to learn binary, which if you want to, let me know. I'll be happy to show you. But just know that for every 1,000, you lose 24. So a kilobyte is approximately 1,000 characters, 1,024 bytes. Megabyte is approximately 1 million characters, or 1,024 kilobytes. Gigabyte is approximately 1 billion characters, or 1,024 megabytes. Bear with me, I'm going somewhere here. So a terabyte equals about 1 trillion, or 1,024 gigabytes. A petabyte equals about 1 quadrillion, or 1,024 terabytes. An exabyte equals 1 quintillion, which is 1,024 petabytes. A zettabyte equals 1 sextillion, which is 1,024 exabytes. A yottabyte equals 1 septillion, which equals about 1,024 zettabytes. Now, our data sizes now are getting up into the zettabytes, which is huge. If you follow the train that I just said, zettabyte is absolutely huge. And one more note here, which is a little bit of fun. The zettabyte is the decimal representation, and again in the geek representation, it's actually a yibabyte. So it's a yottabyte, and then for the geeks, it's a yibabyte, which I just can't wait to hear when they start saying it's a yibabyte. All right, so network speeds. Network speeds. This is another mistake in the book. So network speeds are actually measured in bits, not bytes. And this is important because there are 8 bits in a byte. So for every number that they mentioned, you have to divide by 8. So it's a lowercase b. So megabits and gigabits, not a capital B, were the bytes. Megabytes and gigabytes. Capital B is bytes, lowercase b is bits. So when you pay for services, you're paying for bits, not bytes. So divide by 8. Again, it might not be important, but if you have a business and you are moving a lot of data back and forth, this could make a difference. If you doubt me, check on Cox's website and you will see that it is so. I promise you it's so. All right. So there is, for those of you that are curious, there are a list of services and the data rates and sizes for each one of the services. So DSL, cable, how much capacity a CD can hold, all of that different information are listed on this website here. How data and information travels the internet. So computers are connected to the internet, and they transfer data and information around using servers and clients through transmission media. So again, that can be wired transmission media, so a phone line, a coaxial cable, a fiber optic cable, or it can be wireless transmission media, radio waves, microwaves, satellite signals. So the inner structure of the internet is like a transportation system. So think of the inner structure of the internet like the highways that connect the major cities. So the highways carry the bulk of the traffic, across the country, and that there are several main transmission media that carry the heaviest amount of traffic, and that is called the internet backbone. So I'm going to break here. I'm going to stop the video here, and then that way you have two separate videos and you can watch them independently of each other.